This is 9/11 Freefall.
Good evening, ladies and gentlemen. Welcome to another episode of 9/11 Freefall. My name is Andy Steele, and I am the host. Tonight, we're going to be joined by AE 9/11 Truth's Director of Strategy and Development, Ted Walter, and Dr. Leroy Hulsey, PhD Professor of Civil and Environmental Engineering and a department chair at the University of Alaska Fairbanks. They're going to be giving an update on the World Trade Center 7 study currently underway at that university, and which Dr. Hulsey is overseeing, where they are right now, when the final report is going to be released. And on that final point, I'm going to be giving my own update to you, the supporters, because I know there's a lot of interest in this study. I get asked about it all the time. When is the final report going to come out? It's going to be coming out in August. Originally we said April, but it's been postponed to August. We want to make sure that all of our ducks in a row, that the research is as thorough as possible, and that is why it is coming out at that time, which honestly I think is a much better time for something like this to be released. I mean, think about it. That is going to be close to the September 11th anniversary. That is the time at which the world collectively looks back at this tragic historical event and remembers what they saw that day. And for those who have followed the work of AE 9/11 Truth and have followed the progress of this study, they're going to be thinking back. They're going to be visiting AE 9/11 Truth's website, watching all of the same videos, talking to their friends about it. They're going to be reminded about this important issue, and what a great time for this study to present itself, for its findings to be known by all. So I'm happy about that development, and we're going to need your help out there in the listening audience, all the supporters here at AE 9/11 Truth, and getting the word out to the people that need to hear about it. When the study is published, when the report is final, we need you to spread it around on social media, alert the media in your local areas, national media too, of course. Tell them they need to be covering this important development. They need to be covering this work that has uncovered whether or not NIST findings hold any water. Center of controversy for a number of years, cannot be overlooked. So I'm very excited about this, and Dr. Hulsey goes into some detail tonight about what it takes to put a study like this together. I find that absolutely fascinating. I think you will too. So that is coming your way in just a few moments. Stay tuned.
My name is Leroy Hulsey. I'm a forensic engineer and a professor at the University of Alaska Fairbanks.
Steel is a very fire-resistant material.
When a structure fails, my job is to figure out why. Over the next year, with a team of PhD students, I will be rebuilding World Trade Center Building 7.
How does floor 13 respond with respect to 12?
Using the same drawings that were used to build it originally, we will reconstruct it virtually. Our goal is to figure out why it collapsed late in the afternoon on September 11, 2001, even though it was not hit by an airplane. The investigation conducted by the National Institute of Standards and Technology concluded
what we found was that uncontrolled building fires caused an extraordinary event. The collapse of World Trade Center 7 was primarily due to fires.
Our investigation will evaluate the probability that this was the cause of the collapse. We are making this study open and transparent. Whether you are a physicist, engineer, architect, fire expert, or specialist in another field, or just an ordinary citizen, we want your participation. We are making all of our data available online. Every aspect of our process regarding the modeling will be shared. and we will be giving regular updates from the lab as we continue our work. Join us in getting to the bottom of why World Trade Center 7 collapsed on September 11th, 2001.
The views expressed on this show by guests and the host on issues outside of the 9/11 controlled demolition evidence are the opinions of those individuals alone and do not necessarily reflect those of architects and engineers for 9/11 Truth.
Okay, I am joined by two people partaking in a very important endeavor for a greater understanding of World Trade Center 7 and what brought it down. We've talked about this here on the show before. Now I have the person who is conducting the study. This is Dr. Leroy Hulsey. He has a PhD in structural engineering from the University of Missouri-Rolla. It's now named the University of Missouri Science and Technology. And he's a professor of civil and environmental engineering and a department chair at the University of Alaska Fairbanks. He has extensive teaching and research experience and has also taught at the University of Missouri of Science and Technology and North Carolina State University. Dr. Hulsey has owned and run 3 high-tech engineering research corporations also. And he's joined today by Ted Walter. As many of you know, Ted is the Director of Strategy and Development here at AE 9/11 Truth. He's been involved with a number of 9/11 related campaigns, including the High Rise Safety Initiative and the Remember Building 7 campaign. He's the lead author of the book Beyond Misinformation, What Science Says About the Destruction of World Trade Center Buildings 1, 2, and 7, working really hard to get things like what we're going to talk about today out there. Many people have asked for it for years. We're finally getting it. So guys, welcome to 9/11 Freefall.
Thank you.
Thanks, Andy.
Okay, we're going to start with Dr. Hulsey, and I always give a very brief description of people's backgrounds. Please elaborate on your history, your background, before we get into the stuff about the study.
So I guess what happened is I started off at a young age. As a carpenter, I went from there directly to the university with the intention of becoming an architect. And there were only 2 universities available within the technical community that I valued in the state of Missouri. The one that provided architecture was so expensive we couldn't afford it. So I went ahead and went into engineering, and I found structures to be related. From there, I went to I decided I didn't know enough after I finished my bachelor's, and I continued with my master's. Went to work for an engineering firm in the state of Illinois. Worked there for a number of years. Had an opportunity to work mostly on bridges, but also eventually I did some buildings. And then from there, I decided to go back for my PhD. And at that time, I was already a licensed structural engineer and had been practicing for a number of years. And then went from there to teaching at what is now called MS&T. And while I was working on my PhD, and then from there went to North Carolina State and taught, and another professor and I started a high-tech structural experimental laboratory and a computer center, in which we provided consulting services to industry and to high-tech structural engineering firms. We did a number of buildings through that operation. Primarily forensic engineering is what I was doing at that point in time. Then I kicked off by myself and did that for a while, and then headed up to the University of Alaska Fairbanks, and that was in January 1987. I've been there ever since. And during this time, I've been doing research and development along a number of different lines, from product development to asking questions about various things that come up and a lot of that's been in bridges, and some in buildings, and I'm also in the process of developing different methods for different ways to build buildings these days. we're in a huge developmental change in today's technology. So it's an opportunity for people to do it better, smarter, and for less money. So I'm working in that area quite a bit. So at this point in time, I was honored to be asked, although I turned down the invitation to do this work about 3 times, and eventually we came to, I decided to go ahead and accept the invitation to do the work on the structural collapse of World Trade Center 7. And so as part of that, I recruited 2 students. One was a PhD candidate that was just about to finish his work on what we call structural health monitoring of bridge structures. And then the other student who is still working on his PhD, the other one's finished, and he's working in the area of fires on buildings and high-rise structures. So, which is appropriate. I basically gave him the opportunity to work in that field consistent with what was going on in World Trade Center 7. So that's kind of a quick snapshot of who I am. I'm not the youngest guy on the block, but so I've been around a bit. But I certainly have a passion as being around young people all the time about trying to have enough energy to do this thing and do it extremely well.
Well, I can hear the passion in your voice, and as you describe all the latest developments in the profession, the fact that you keep up on these things, it shows that you're really into what you're doing. You obviously chose the right life path, which I think is what people need to do, to really stay active and stay involved in this world. And I think that's the true happiness, is when you can kind of have the key fit into the lock and turn and find what your life's mission is. So it sounds like you've found it. So moving forward, before we get into more details about the study, you've been described as a forensic engineer. For people kind of new to this issue, new to engineering itself, can you describe what a forensic engineer does?
Well, just imagine, for example, that somebody built a building and one part of it failed or did not function as correct as it should. Or just imagine that you might have an automobile and you got into an accident and somebody got thrown out the door. And the question is, who's responsible for that? Well, the forensic engineer oftentimes gets involved in those kinds of situations where, was it because of the accident that produced that door to fly open, or was it a faulty design to begin with that created the problem that maybe it shouldn't have been thrown open? So forensic engineer goes in and almost becomes like a Sherlock Holmes, begins to investigate in detail what should have been looked at or wasn't looked at or was looked at, and try to assess the situation for what was going on at the time. And so an example of a simple thing that might clarify a little bit about a forensic engineer, I was involved in a project in North Carolina where it wasn't a tall building, but it was a kind of like a Walmart or a Kmart, where the contractor was putting up a metal building. They had it up, but they didn't have it completely covered. They went home for the weekend. A wind came through and blew it down. And so the question is, was the contractor responsible? Was the supplier responsible? And so then we got involved and looked at all the pieces of the puzzle, and then had a report. And that was forensic engineering, evaluating the cause, evaluating the failure, and coming up with the reason and who, not necessarily who, but certainly the cause of the failure.
Well, this is an important thing to study, too, because there's issues of liability involved when things go wrong. People certainly want to know why certain kinds of structures fail to prevent them from happening again. This is completely, of course, applicable to the issue of World Trade Center 7. Amazingly, many people, including at NIST, from what I've seen, show very little interest in exploring it further than what they did in the official reports, which we've found have had many issues, very well documented on this show and by others associated with AE 9/11 Truth, and we'll get into that in just a moment. But just to give some further background for new listeners, we're going to have Ted chime in here. And Ted, can you remind our audience what the study is really about and why AE 9/11 Truth decided to pursue it?
Sure, absolutely. So I think as many listeners are aware of, this 47-story building, World Trade Center Building 7, collapsed symmetrically into its footprint late in the day on 9/11. And the questions about what caused this building to come down the way it did have been quite debated for many years. And, Architects and Engineers for 9/11 Truth was founded in order to raise awareness and get to the bottom of why Building 7, as well as the Twin Towers, came down catastrophically on 9/11, when fires have never brought down a steel-framed high-rise before 9/11. And the National Institute of Standards and Technology issued a report in 2008 on Building 7. Their reports on the Twin Towers came out in 2005. But in 2008, the Building 7 report came out. And since then, engineers, mostly those associated with AE 9/11 Truth, have been, really dissecting the NIST report and critiquing many of its claims and finding that the theory that NIST put forward for how, in particular, how the collapse initiated, or how the series of structural failures initiated, is really unsupported, and relies on sort of many falsifications or of what we now know was the structure of Building 7. Certain structural features, for example, that NIST omitted from its structural computer models in order to allow for this rather elaborate sequence of structural failures to allegedly occur in their model. And one of the problems that we've had, we can document a lot of this, but we really felt that we needed to go a step further. And since we couldn't run the NIST models ourselves, in large part because they refused to release all of the modeling data associated with their study, we realized that it was essential that we somehow, make another study happen and to get an independent answer on why Building 7 came down and whether the story that we have been given by NIST is valid. And really, it's a matter of, I know for a lot of listeners out there, a lot of folks will look at the collapse of Building 7, the nature of it, and kind of, realize right away that the most likely hypothesis or the most likely explanation for the building's collapse is that it was due to a controlled demolition, given how it came down, given that fires can only weaken steel so much and many other factors. But we, as engineers and architects, we need to go a step further and demonstrate our hypothesis, demonstrate the validity of our hypothesis through computer modeling, and specifically by in great detail and with great accuracy, simulating how Building 7 would behave when it's subjected to fires and extreme heating. And so we, over the course of the last few years, and some of this happened prior to my working full time at Architects and Engineers for 9/11 Truth, but I understand Dr. Hulsey was approached some years ago, and eventually, right around the time when I became involved and started working full time for AE 9/11 Truth, we did basically get this agreement going with Dr. Hulsey to study the collapse of Building 7, and we entered into, and this would be May of 2015, we finally entered into a contract with the University of Alaska Fairbanks to conduct this study. And that's where we are now, almost 2 years later.
Now, I'm curious, Dr. Hulsey, you've been approached before for this study, but up until somebody had approached you to do the study for the first time, had you ever heard of the controversy surrounding World Trade Center 7?
I suppose surprisingly not, no. I was not aware of it. And, I was certainly aware of the Twin Towers. Certainly when that came down, I was teaching steel design in a class, and I was surprised by even the theories that had been proposed for the failures of those two buildings. But there was no discussion whatsoever that I was aware of about World Trade Center 7. And perhaps I should have been, but I just was not aware of it. And I can tell you, in talking with a lot of people out there, that unless people have passion about this subject, there is probably a lot of people that were not aware of this controversy, this building coming down that day.
Right. There's a lot of people out there who have never heard of this building before. In fact, at one point, the Remember Building 7 campaign was called Building What? Because a judge said that during a court case related to the issue. So it really brings home why this is so important. Again, even if you believed the official story, this would be a colossal event that should be studied by engineers, architects the world over to prevent something like this from happening. Again, that's why your work is so valuable and why we're so happy that this is finally coming. Again, people have asked us about this for years. They would write to AE 9/11 Truth asking that something like what you are doing right now be done. They'd even write into 9/11 Freefall asking me, you know. So yeah, there's a lot of interest in this. And it's funny because there's a lot of interest and people want to see what the outcome is. But I don't know if a lot of people know some of the work that is involved in putting something like this together. In fact, I have a lot to learn on that myself. So, Dr. Hulsey, can you kind of go over how you go about starting something like this? Talk about some of the work that goes into developing a study like this.
Let me begin by telling you a little bit about my philosophy about this, because it's really important that everybody understand. There's all these different hypotheses out there from one extreme to another on what may have happened with this building, and so right away I completely closed that opportunity to talk about any of those theories, because what we need to do is to take a look at the science and let the science take us where we need to go. And so for that reason, I have been really resistant until lately, looking at all the different kinds of things that are discussed and say, okay, we begin by taking the information that we can get about the building, which were the erection files on the building, which basically enabled us to take some very, very large number of documents that are basically the plans on which they put up the building with. And we then put that into an AutoCAD file. And an AutoCAD file is basically a drawing file that's digitally prepared and enables you to actually install the building electronically. In other words, you end up with a virtual look at the building, three-dimensionally, which means that every beam, every girder, every floor, everything is put back together, and you can look at it on a screen, and you can see that it looks like the building it was built. That's what we did first. And since we had two students, PhD students, and myself, I had each one of them checking each other every day, and then I would check them and establish a quality control to be sure that the entire building was being put together as if it was built, so that if you did not do that and you didn't make these checks, then you could actually run a computer analysis to try to understand what happened. And it might not be the same building. It might be something else. So it's absolutely critical that when you do a study like this and evaluate it, you need to be absolutely accurate in every little detail to ensure that everything's correct. So we did that. We put all the materials in, the floors in, everything. And then from there, we then imported it into two different computer programs. One is called Abacus, which is basically enables you to almost look at the microstructure piece by piece. It's highly accurate. It's a finite element program. Its finite element programs by their pure nature are not exact, but as you refine the mesh, almost like a crossword puzzle, get the pieces smaller and smaller and smaller, they get more closely approximating exactly what's there. And so we ended up, taking a look at how fine a mesh we need to have to make sure that we got a good representation of what the building was feeling. We also had another program that we used, which is SolidWorks, that we used for heat transfer of the materials when they were heated up, how they behaved, how the heat might transfer through the floors, through the ceilings, through the steel, and so forth. And then we had a third program, which we're using now almost exclusively, which is SAP 2000. And so that program we're using to do what's called a progressive collapse. In other words, what really went on here? What could have caused this building to come down? When you look at the video, you see it coming down a certain way. And so what do you need to do to make it come down like that? I mean, that's a progressive collapse scenario. So basically, what we did is we took the information that we had available. That's available. We would love to have more information, but we took the information that we had available, put this building back together as if we were building it in the real world, and we created electronic digital version, virtual building that you can actually see on a screen. And then we imported that into the computer program and then conducted analyses on it based upon the various conditions that we might want to look at. As an example, the argument is that by NIST that on September 11th, 2001, WTC-7 endured fires for almost 7 hours from the time of the collapse of that North WTC Tower 1 at 10:28:22 a.m. until 5:20:52 p.m. in the afternoon, WTC-7 collapsed. So one might argue, okay, that was caused by fire. That's what they're saying. So when fires happen, particularly with steel, if it's not well protected, the heat does enormous damage to the steel in that it begins to weaken. And so one might argue, okay, that heat, that weakening would cause the structural elements not to be able to carry the loads they were once designed for, and therefore it would make sense the thing would come down. But NIST argues that the heat from that uncontrollable fire caused the steel floor beams and girders to thermally expand, leading to a chain of events that caused the key structural element columns, which is big. The big argument is column 79 to fail, and the failure of that structural column then initiated a fire-induced progressive collapse of the entire building. Well, that wasn't about weakening of the steel. That was about expansion of the floor system and pushing it so that the bearing support at column 79 was lost, and therefore the lateral support of that column then was not available, and then there was a continuation of the next floor down and next floor down until eventually that column was not able to carry, could not withstand the load that was on it from the dead load up above, and so it formulated a progressive collapse. That's their theory. So what we're doing now is examining various aspects of that using progressive collapses. We're just starting that process. Up until just very recently, we've spent a huge amount of time just addressing that question of the thermal expansion. And I guess I probably should share with you and the audience the fact that there's some differences in what we found versus what the NIST report did find. So our objectives of this UAF study is to evaluate findings for the collapse presented by NIST. So we're looking at their collapse mechanisms, what did cause the collapse, examine progressive collapse mechanisms, and then provide a summary of our findings and conclusions. And then that is where is our objective. Okay. So what I wanted to kind of give you an idea about is, okay, if this building was going to thermally expand, then there's a lot of questions that you end up raising because of it. And so how much paper is going to be around? What's the combustibles available to cause a fire to be going on for 7 hours? And if it is, when is all the material going to be burned up? So there's questions there that one has to ask themselves about. But let's just put that aside and say, okay, let's examine the worst conditions. So assuming that the fire does actually occur, then the next series of questions that you might start asking, okay, was there fire protection on the steel? Was there fire protection such that the steel didn't get so hot as to have a problem? Were the sprinklers activated? And were they working, or did all the water get used up because of World Trade Center 1 and 2? I mean, there's a number of questions associated with all of that. But under the worst scenario, we'll just say, okay, all that stuff goes away, and we have a fire situation, and we find that, okay, it thermally expanded. So there was a number of discussions about what people have argued with other researchers and other investigators that the stiffeners at that column were not included in the study by NIST, which was inaccurate because they actually did exist. There was an argument about the shear connectors on the girders not being there, so therefore the floor system, the girders were able to move with respect to the floor system, and so therefore that issue was not what we would call a composite system. There were shear connectors on those girders, surprisingly enough. And so even without them, we studied that without them, and with all the shear connectors on the beams and so forth, we determined that that was not an issue because enough shear connectors were available on the beams to make the whole system work together, and that would not have caused a problem. And by the way, even with all that being said, there's still a lot of frictional resistance between the concrete floor system and the beams it's sitting on. So with all of that, we looked at the expansion question and modeled it as if NIST did, and we got very similar results, almost very, very close. I think they had 5.5 initially. I think ours is about 5.1, something like that. Same direction. However, there was certain assumptions that they made that is quite interesting. And I'm not sure exactly what the motivation was, but they treated the exterior frame as rigid. They treated the connections were not the same on the entire part of the floor. They pulled out part of the floor and put in the connections to the other part of the floor. They did not. And so all those differences tend to aggravate an expansive question because if you have a beam and you hold it on one end of it, and you heat that beam up or heat up a piece of metal, it's going to expand away from that place you're holding it. So if you take it and hold it on the other end and heat it up, it's going to go the other way. So what happens is when you heat up something, it's going to try to move with respect to the stiffest spot. And so all of those things being said, those connections and how the building was actually built really affects that question a lot. And so therefore we spent a lot of time making sure that we modeled those connections accurately as if it was built and tried to make sure that we understood exactly how that went together. We also spent a lot of time thinking about the concrete deck, the concrete slab. It's a 3,500 PSI concrete. The question is what kind of aggregate is in there? And so we attempted to try to get an aggregate that actually matches what might have been used at that location, because it's an aggregate source that would be local, and we matched our aggregate source to the concrete to try to attempt to get the thermal conductivity and coefficient of thermal expansion of that deck accurately measured. And we used the literature and some paper that I'd written a few years earlier on that subject to correlate that against actually what the steel conductivity and thermal expansion might be. And so therefore, we put all that stuff in and let that thing expand. And we did, however, use a thermal model that NIST provided for the fire. We did our own as well, but we felt like the NIST one was conservative. It was probably may have been more than what actually occurred, but that's okay. Can we create a situation here that would explain a failure? And so, with all that being said, we were not able to do that. It actually moved to the east instead of to the west, as NIST said it. And with all that being said, and it didn't move nearly as much. And so, therefore, that, in our judgment, that did not actually occur. So it has to be something else. And so that now we're looking at other causes of what may have produced this failure. And so that's what we're looking at right now. And so in order to do that, we're accurately trying to look at the different aspects of what might have impacted this building. Certainly some damage occurred in the exterior, but not very significant. When debris from the World Trade, the Twin Towers came flying out there, it's about, some distance away, about 100 yards away or something. Some of the debris went through the windows, causing the fire. There was damage on a couple of exterior columns, not that significant, but it did do some damage. The question I'm looking at right now, and we're not anywhere near the solution yet, but we're looking at it. And I haven't seen anybody else doing much with this, and maybe it's not significant, but I just want to put the question to rest. So how much vibration actually occurred when these Twin Towers came down? And so there are accelerometers out there that actually monitored this for Twin Tower 1 and Twin Tower 2 at the different times. And so we're going to take a look at that vibration response and see what that may have done to the building. It's excitation. We do a time history analysis on the building, on a spectrum analysis, and see what we might find, if anything, from that. The other thing we're looking at is to take a look at what about the shock waves. I'm not talking about now the vibrational response of the ground. I'm talking about the shock waves of the air as it's pushing. What might that have done in terms of causing a lateral force on that building at that time? Keep in mind, though, these are hours earlier, so it's not at the same time. So even if any of that occurred, there would have been a fairly significant delay. And so anyway, we're looking at that. I'm also taking a look at the lower section of the building, which I haven't seen anybody else doing, to see if maybe there was a foundation issue. It was built on the substation, and I really haven't. I've asked this question multiple times. I don't have really good answers, but I'm still concerned about that issue because if the foundation goes, then the rest of the building goes. So anyway, that being said, that's kind of a snapshot of what we're doing and what's going on. You got to remember that this building was built it actually started. The developer was Silverstein Properties. It was actually started in 1983. Construction was completed in 1987. The height from the ground to the roof was 610 feet, 47 floors, 2 million square feet of space. There was 32 elevators, and so that's kind of the building as we know it, as it was at the time.
I was just going to say, it sounds like it's so detailed, what you are doing, looking into every aspect, that even stuff that I haven't even thought of. I mean, it's just amazing, all the work that goes into this, and to recreate a building piece by piece on the computer, following the drawings and all the available information. That must be a tremendous challenge, and you're going to be coming to the end of your work pretty soon here. I want to know about challenges along the way. This has been alluded to earlier. I know there's issues like availability of information, from NIST and what they did and all of this stuff. But what kind of challenges have you run into in trying to get this study done?
Well, we're always running into challenges dealing with not as much information as we would like. So what we intend to do is to take and bound it. So bounding means what's the worst scenario that possible based on where we are and what's the best information. And if it doesn't matter, then you can put that to rest. If it's sensitive to that lack of information, then you've got to put it on the side and say, okay, we've got to look at this again. And as we get further along, then we go back and revisit it. So not much of that have we dealt with yet. We haven't had to worry about that very much, actually, quite frankly. So what really we ran into, which has made it simpler, is that when we couldn't take the worst scenario that we've got and cause the building to come down because of the fire question, then a lot of that becomes kind of an academic issue. Then it's got to be something else that's causing this thing to come down. So anyway, that's kind of how we've been, looking at that whole issue. What would have been really, really, really wonderful, and I'm surprised that it happened, is that everything pretty much was hauled away. So I've never been involved in a forensic engineering issue ever, where all the stuff was hauled away and you had nothing to work with. So you basically go out and you crawl around in the debris, and you get samples, and you get samples of everything you're looking for. You study it, you take pictures of it, you write reports on it, you look at metallurgical and petrographic evaluations of every little piece in detail, and you start taking this and putting it back together. Just like if there's an airplane crash, you go and take that plane, you put it together again to see what might have caused that problem. We don't have that luxury here. We have to do it in a very much more difficult situation. And there's our pieces of the puzzle out there, but they're not the ideal.
Well, and that's famously cited many times throughout the years about all of the the evidence that has just been wiped away immediately before anybody even really started questioning what happened to these buildings. A lot of people still in shock, of course, after the event took place. And by the time people had that wear off, started wanting to take a look at some of this evidence for themselves, it was no longer available. So I can see how that would be challenging. And something I want to just focus in on right now is the worst case and best case scenarios. It sounds like you're running different scenarios. And indeed, over the years, there's been a lot of different theories put forth as to why World Trade Center 7 went down, theories having nothing to do with the evidence that we cite, and theories that have nothing to do with what NIST claims that happened. People have come up with their own ideas. Some of them have stuck in the minds of the general public when they debate about this on internet forums and whatnot. How many kinds of scenarios are you going to be looking at? Are you going to be looking at, for instance, if some other occurrence other than explosives or the failure at column 79, are you going to be looking at other scenarios beyond those as well?
I don't know. It's not my intention to look at always different arguments. What I'm in the process of doing is saying the following. What has to happen for this building to come down the way it did? That's what I'm simulating. And we will know when we get done with this, and we'll know this pretty soon, is how sensitive is it to that question? What has to literally occur to make that happen? Because if you look at the NIST computer model, it doesn't look anything like the failure that actually occurred. Furthermore, if you look at the actual building and it's coming down, it's really quite remarkable that if you look at the sheathing, which is the exterior part of the building that's connected to the structure, you don't see any wrinkles or cracks or anything else, which is saying that they weren't experiencing any distress. That being said, that means the thing had to be coming down as a block, which opens up a lot of questions.
Indeed it does, and we've been asking these questions for a long time here. Just on a personal basis, anytime I do any kind of project in my field or pursue any kind of new avenues of work, I always learn new things along the way, and it's just kind of interesting what I take from each new thing that comes my way. Have you learned anything along the way in doing this study?
Well, I learn every day. Every day is something new. So, I mean, not just in this study. Everything I do is there's always a new piece of information, a new day, builds a better background as I move forward, to try to do a better job. So, yeah, every day is an experience. So I know that NIST, for example, used a program called Fire Dynamic Analysis, FDS, to simulate their fire. They also used a structural interface analysis and structural response to fires using a program called ANSYS, which is a really good program. They also used LS Dyna to actually look at the progressive collapse. They use different programs than we're using. And it's my understanding, I could be wrong, but it's my understanding that some of their analyses took hours and hours and hours to actually run. And we've worked really hard to make sure that we don't have that issue. And you might say, okay, how did you get around it? We're using substructuring techniques to enable us to still model this accurately, but enable us to get runs out pretty quickly. So we can look at a lot of scenarios much faster because we're not bogged down by hours and days to get out a run to see what might have happened. And that has really been a lifesaver because we can actually get a lot of information fairly quickly through that process. And through that, right now, by doing that, every single run we learn something new. Oh, really? That's what's going on. Why did that building do that? I mean, so all those kind of questions keep coming up over and over and over again, which means that if you maintain an open mind and not try to say this is what's going to happen, but have a background of what you think might be going to happen, then you can go back and question it scientifically and evaluate, okay, what's the basis of why that happened, and see if it makes sense. And so that's why each of the three people have argued back and forth every single day that we make these runs to check and evaluate and question everything that we're doing.
And I think this goes into the issue, too, of transparency. That's very important because we know the people who don't like us asking these questions about World Trade Center 7 are really going to be scrutinizing this study. And I want to ask first Leroy and then Ted, because there's two ends of this. On Leroy's end at the University of Alaska Fairbanks, and then Ted's end at AE 9/11 Truth. What are we doing to assure transparency, provide it for people that might be interested in this study?
Well, it was my intention all along to provide complete transparency. And we just got so bogged down in all the analysis that we haven't made it available that quickly. But we are going to make it available, all the computer runs, all the data that we've got. And so people can, if they want to go and run the Abacus program or run the SAP program, they'll have the data files there to be able to do it. That's not been done before, to my knowledge. The other thing is that we trying to build the arguments, and we have hopefully sometime in May, hopefully we'll have a peer review committee to scrutinize and evaluate and criticize everything that we've done. And so at that point, it's my intention to be able to respond to those criticisms and be able to take, and we're talking about scientific criticisms here, not just arguments, but about why did you do that? Is this true? Why isn't it this way? What's going on here? And so that we can actually respond to those questions and do it scientifically. And once all that's been done, I would hope, no matter how a person's feelings might be, that the scientific community, on whatever side of the argument they might be on, would be willing to say, okay, science is where it ought to be, and we all then can learn and benefit from this horrific event that occurred on September 11th. And so if we as engineers and scientists can move forward with a knowledge that, okay, this is what must have happened, then we can either then logically decide whether there needs to be some code modifications or needs to be no change, and it was an event that should never have occurred and it should never occur ever again. So anyway, that's my thinking about that.
Ted, what's your add-on to that?
Yeah, really just to reiterate what Dr. Hulsey said about making all of the data available on the website, on UAF's website, as well as Architects and Engineers for 9/11 Truth, our website for the study, WTC7evaluation.org. We want to make all of it available so that that people can look at the data and if they're capable, run the analysis themselves. And in the end, I would hope that anybody that wants to level any serious criticism of the study will do it, based on the merits of the study, and look at the analysis that Dr. Hulsey has done, look at the assumptions that were made, and that's where the discussion will be, and we won't see some of the more negative, non-technical hurling of insults and whatnot that sometimes accompanies this issue. I think it's very clear that Dr. Hulsey and the University of Alaska Fairbanks are bringing a very responsible, professional, technically sophisticated, and objective mindset to evaluating this problem. And so Dr. Hulsey's analysis deserves to be looked at and critiqued on that level and no other level. So that's it. And one thing, that everyone should be aware of is that the study, the final report for the study, is going to be released in August 2017. So 3 or 4 months from now, and that will be right before the September 11th anniversary. And we're really looking forward to the release of the study, and we will be on our side at Architects and Engineers for 9/11 Truth, working very hard to ensure that when Dr. Hulsey releases his final report, that a lot of attention will be paid to it, whether that's by the mainstream media or by other people in the engineering field. This is a very serious undertaking that we've been engaged in for the last 2 years, and that the world has been engaged in for the last 15 years. And Dr. Hulsey's research warrants that kind of attention, we believe. So we're really looking forward to it, and we're very grateful for the support that so many of our supporters have given to this study over the last 2 years. This study would not have been viable without the support of thousands of people out there who are dedicated to finding out the truth about what happened on September 11th.
Now, I'm going to ask both of you a question, and it's a little bit more philosophical in nature, I guess, but starting with Dr. Hulsey, in the end, when this is completed, what will you be most proud of having contributed to this debate? What holes do you feel have been left in this debate that you'll have filled? And again, I guess, what will you be most proud of for having contributed this study?
Well, I think from my perspective, being a professor and a researcher and a teacher of to students and so forth, the opportunity to get a better understanding of a very complicated structural system and actually have some idea of what may actually have happened in that collapse. That would be historic. That would be a great learning experience for everyone. Anytime that there's a forensic issue, we should come out of that with better knowledge and better understanding to avoid anything like that ever happening again.
Ted, same question to you.
Well, I think that the most important thing that this study will accomplish is a independent and totally transparent evaluation of what could have brought down Building 7. And we at Architects and Engineers for 9/11 Truth feel that the public has not been given that yet. And we know that Dr. Hulsey, on the other hand, has undertaken a totally unbiased, objective study of what could have happened to Building 7. And we're grateful to the University of Alaska Fairbanks, as well as Dr. Hulsey, for having the courage to take on this issue, this question that we know has been controversial, and handle it in such a professional way. And so that's what we will have accomplished by the end of this process.
Absolutely, and I think this is the best way to go about it. Again, we've been asked for this for a number of years. It's finally happening. A lot of people ask me what's going on with this project, and so I guess this is our update here on 9/11 Freefall tonight with Dr. Leroy Hulsey and Ted Walter telling you where we're at, and it's great news that it'll be coming out in the late summer. And Ted, just as a final word to supporters, there may be people who are just learning about this for the first time, may have figured out there's problems with the official story recently, and may have even forgotten about this study since we first started talking about it. How can supporters help out? We've talked about how supporters have helped out already and their great contributions to AE, helping make this happen. But for people who still want to do something, still want to be a part of this important project and contribute something to history, how can they help us out?
Well, the first way is for people to understand that we're still paying the bills. We're still paying the University of Alaska Fairbanks. And so any help that people can give goes a long way to helping us finish funding this study. And you can simply go to WTC7evaluation.org. Again, that's WTC7evaluation.org and make a donation. It is a tax-deductible donation because we are a 501c3 nonprofit organization. And then the other thing, and this is the most important thing, is when the study comes out and people have the final report, is to share it as widely as possible. Send it to everybody that you know. A lot of what's written in that report will be fairly technical, but I'm sure that it will be explained in a way that people can have some key takeaways about what could and what could not have caused Building 7 to collapse. And, last year we published an article in Europhysics News that's now been read over 500,000 times. And I anticipate that this study will attract the same kind of attention, if not more. And so people can be a part of that, of spreading the awareness of Dr. Hulsey's findings.
I expect that, too. These are exciting times for people who have stuck with this issue all of these years. So much people's energy put into trying to get a new investigation going. And this is sort of a new investigation being done by the Alaska Fairbanks, University of Alaska Fairbanks there. So this is good stuff happening. And I want to thank the supporters for all the help they've given. And good times are ahead. Dr. Hulsey, Ted, thank you so much for coming on 9/11 Free Fall today, giving us this update, and good luck in your endeavors and in the finished product.
Thank you very much.
Thanks, Andy.
This program is on every Thursday night on No Lies Radio at 10 o'clock Eastern, 7 o'clock Pacific. You can also keep track of the archives by going to 911freefall.com. This is Andy Steele saying have a great week and good luck.